Hello everyone. Today we are going to understand how do we carry out reactions of KMnO4, that is potassium permanganate, in neutral or slightly alkaline medium. Last lecture we have studied about KMnO4 and acidic medium, so please have a look at it. Okay. Now over here, when we talk about KMnO4, potassium permanganate, if we split this particular compound, we are bound to get potassium ions and permanganate ions. Okay, so over here, MnO4 1 minus. We are going to utilize this permanganate ions for our reactions. Always remember that permanganate ion splits into two ways. If suppose we are talking about acidic medium, then in acidic medium, permanganate ions get converted to Mn2 plus. And if we are talking about neutral medium or alkaline medium, our permanganate ions get converted into manganese dioxide, so MnO2. We are going to focus on this. So in this particular lecture, we are going to discuss reactions which will be converting permanganate ions in the neutral medium to MnO2. Let's see how this works. MnO4 minus getting converted to MnO2. Okay, now I told you we are utilizing neutral medium. So we need to add over here water. Now, how much water do we need to add? See, here there are 4 oxygens. Here we have 2 oxygens. Okay. So technically in the reactant side, we have 2 extra oxygens. The key is to remember how many extra oxygens are there, that many water molecules need to be utilized. So out of 4 oxygens on the reactant, only 2 have been utilized to make the product. So there are 2 extra in the reactant side. So we are going to add 2 water molecules. Now let's have a look at it. 2 water molecules means what? 2 water molecules meaning 4 protons are going to be there, or we can say 4 hydrogens for that matter. Okay. 4 hydrogens and 2 oxygen. Now see, if you look at it carefully, what do we get to see? Technically, there are 6 oxygens. 6 oxygens, and we need only 2 oxygens on the product side. So this 6 oxygen is going to split into 2 ways. What are the 2 ways? 2 oxygens get utilized to give you MnO2, and the remaining 4 oxygens combine with the hydrogens, 4 hydrogens, to give you 4 OH minus hydroxyl ions. Okay, this is an alkaline or neutral medium situation. That's why we are not generating protons, rather we are generating hydroxyl ions. Okay, so if you want to go through it again, let's check that again, no problem. What is happening over here? We have in the alkaline medium or in the neutral medium, we are going to add water molecules. How to decide how many water molecules need to be added? Okay, so let's check over here. 4 oxygen, 2 oxygen. How many extra oxygens are on the reactant side? There are 2 extra oxygens, right? So right over here, 4 oxygens from MnO4. Now, the number of extra oxygens are 2, right, on the reactant side. So you utilize 2 water molecules. These 2 water molecules split as what? 2 oxygens, 4 hydrogens, right? So see over here, we have 4 plus 2. How many oxygens on the reactant side now? We have 6 oxygens. These 6 oxygens split. 2 oxygens are used up in making the main product, that is MnO2. And the 4 oxygens which are over here, They combined with these 4 hydrogens to give you 4 hydroxyl ions. Hydroxyl because we are in slightly basic or neutral medium, right? So how many OH are generated? 4 OH. So write over here 4 OH minus. Okay. Now check the charge. Always remember to consider the charges or the ions. Here we have -1 charge, 0 charge. So a completely stable compound would always carry a 0 charge. And here there are -4 charges. So reactant side has only -1 charge, product side has -4 charges. So to balance, we are going to do what? We are going to add 3 electrons on the reactant side. So -1 minus 3 gives you -4. So what is our original reaction now that we need to consider? It would be MnO4 1 minus plus 2 water molecules plus 3 electrons giving you MnO2 plus 4 hydroxyls. Another best way to remember is consider or check how many extra how many extra oxygens are there and write down the number of water molecules. So if 2 extra oxygens are there, 2 water molecules are required. Double that number to get your hydroxyl. So if 2 water molecules are utilized, 4 hydroxyls will generally be released. Okay. So please make sure you understand the general equation of KMnO4 or permanganate ion in neutral medium. Utilizing this general equation, we are going to solve our first question. First question is oxidize iodide to iodate. What is the first step? First step, write down. What do we write down? Our general equation in neutral medium. MnO4 1 minus plus 2H2O plus 3 electrons giving you MnO2 plus 4OH minus. This is our general equation in neutral medium. What do we need to consider? We need to convert I minus, that is iodide, to IO3 minus, that is iodide. See over here in the product, we have 3 extra oxygens. So on the product side only, we are going to add 3 water molecules. What did I tell you? The number of water molecules you add, double that number and add the hydroxyls on the other side. So it becomes 6OH minus. Let's see the charges over here. What charges are we looking at? 6 negative charges, 1 negative charge, 1 negative charge, 0. So can you see on the reactant side, we have -7 charge, whereas on the product side, we have only -1. So what do? We are going to add 6 electrons on the product side. 6 electrons added. Now you can see -1 minus 6 is -7. Okay, always remember balancing the charges is a prime function. You cannot skip it, otherwise your entire stoichiometry would double. Okay, now let's check what are we getting. There are 3 electrons in the first reaction and there are 6 electrons in the second reaction. According to scientific convention of reaction, we should avoid involving electrons in our complete reaction. So if we don't want electrons to be present, we need to equate the electrons so as to cancel it. Now 6 and 3, what's common? 6 common, right? 6 ones are 6 and 3 twos are 6. So multiply the first equation by 2 and multiply the second equation by 1. So technically the second equation stays the same. Let's see how this looks like. 2MnO4 1 minus plus 4H2O plus 6 electrons giving you 2MnO2 plus 8OH minus. Second reaction stays as it is, 6OH minus plus I minus, giving you IO3 minus plus 3H2O plus 6 electrons. What all gets cancelled? Let's first look at it. 6 electrons are going to get cancelled. What else? Can you see 3H2O, 4H2O? So what is pending? 1H2O. Okay. Can you see over here there are 6 hydroxyls, right? And on the first reaction, we have 8 hydroxyls. Cancel them. 2OH minus. So what is our final equation? Right? All the reactants on one side, all the products on the other side. 2MnO4 minus plus 1H2O plus 1 iodide, giving you 2MnO2 plus 2OH minus plus IO3 iodide. And this is your actual equation. So what all things we need to do? Let's try to recap. First, we need to remember the general equation of MnO4 minus in neutral medium. Once we have that, we need to have our question. So in question paper, you will be getting iodide to iodate. So first write down iodide and iodate. Check where or on which side we have extra oxygen. So the number of extra oxygens, that would be a number of water molecules used. And on the other side, you are going to double that number and give hydroxyls. Third step would be writing out and balancing electrons. Okay, so once you balance the electron, you're going to rewrite the equation, cancel out whatever can be done, and you get your final equation that way. Try to pause the video, go through it again. Okay, for the first, I think, couple of times, you might get a bit confused while you're doing it by yourself. But later on, as you watch the video, you realize that, okay, it's a simple formula. Extra oxygen, add water on that side, double the number of water and write hydroxyls on the other side. You know, write down the electrons, balance them up, and you get your final equation. Keeping that in mind, let's check out another one, thiosulfate to sulfate. So first write down the general equation. General equation is MnO4 1 minus plus 2H2O plus 3 electrons give you MnO2 plus 4OH minus. What is our secondary equation? Thiosulfate, S2O32 minus, getting converted to sulfate, SO42 minus. First things first, 2 sulfurs are used. We need to put 2 over here as coefficient. Now let's check. We have 3 oxygens over here. We have 2 4s are 8 oxygens over here. So how many extra oxygens do we have? We have 5 extra oxygens. So how many more water molecules? 5 water molecules. Double that number. What do we get? 10. 10 hydroxyls. Okay. So we have 5 water molecules because there are 5 extra oxygens on the product side. So we are going to double that number up and get our hydroxyls on the other side. Okay. Now let's try to understand the number of electrons and charges. 10 electrons, 10 charges, minus 10, minus 2. Together they form minus 12. Here 2 2s are 4, minus 4. And water has 0. So total charge minus 4. So minus 4, how many electrons do we need to add to make it 12? We need to add 8 electrons, right? So -4 minus 8 gives you -12. This is how we construct our secondary equation as well. Did we require any extra information? No. We took the information from the question sheet and we directly put it on our paper. We calculated which side has more number of oxygen, and on that side we added our water. Doubling that number up, on the other side we added our hydroxyls and balanced out the electrons. Okay. Now let's see. 3 electrons in the first reaction, 8 electrons in the second reaction. 3 8s are 24. So we are going to take the LCM 24 and go ahead with it. So the first reaction gets multiplied by 8, whereas the second reaction gets multiplied by 3. You need to equalize it. There is no other number we can equate it with. That's why we are going to go for LCM. Okay, so this becomes 8 MnO4 1 minus plus 16 H2O plus 24 electrons, giving you 8 MnO2 plus 8 4s are 32 OH minus. Here 3 10s are 30 OH minus plus 3S2O3 2 minus. Okay, 3 2s are 6 sulfates and 3 5s are 15 H2O and 3 8s are 24 electrons. Now let's see what things can be cancelled out and how we can go about it. Okay, first of all, 24 electrons cancelled. 15 H2O, 16 H2O, 1 H2O pending, right? 30 OH minus, 32 OH minus, 2 OH minus pending. So opposite sides, whenever we have now, we can cancel them out. Let's see over here, our final equation would be all the reactants on one side. So 8 MnO4 1 minus, 1 H2O, 3 thiosulfates, giving you 8 MnO2, 2 OH minus, plus 6 sulfates. And that is how you get your final equation. Steps are the same, nothing different. I didn't take help of anything else apart from the question and general equation. Okay. The last one, if possible, you can pause the video over here. Try it by yourself. On the other hand, once you just resume, you might even see the answer over here. Okay, manganese salt, Mn2 plus to manganese dioxide, MnO2. Let's see how things go. MnO4, general equation first. MnO4 1 minus plus 2H2O plus 3 electrons, giving you MnO2 plus 4OH minus. What are we converting? We are converting manganese salt, that is Mn2 plus, to manganese dioxide, that is MnO2. Right? Let's try to see over here. Reactant has no oxygen, but product has oxygen. How many oxygens extra? 2 oxygens. So add 2 water molecules. Double the number, add on the other side 4 hydroxyls. I hope this much should be clear by now. Okay, see over here. -4 charge plus 2 charge. Together, -4 plus 2, -2. Here, 0 charge, 0 charge. There are no charges. So total 0. What do we need to do in order to balance the reaction? We need to add 2 electrons on the other side. So 0 minus 2 is -2. Okay. With some practice, this thing becomes relatively simple and easy. So please do not give up if the first time seems a bit tough for you. Okay. Now let's check how things are working. We have 3 electrons, first reaction. We have 2 electrons, second reaction. What do? Our logic is pretty simple. 2 3s are 6, LCM, right? So let's pick up an LCM. Okay, you can do this by yourself. 2, we multiply the first equation by 2. We multiply the second equation by 3. Let's see. 2MnO4 1 minus plus 4H2O plus 6 electrons, giving you 2MnO2 plus 2 fours are 8 OH minus. Here 3 fours are 12 OH minus plus 3 Mn2 plus, giving you 3 MnO2 plus 2 threes are 6 H2O, 2 threes are 6 electrons. Now let's see what all things can be cancelled over here. First of all, 6 electrons, 6 electron cancelled, right? Then what do we have? 12 OH minus, 8 OH minus. How many do we have? 4 OH minus extra on this side. 6 H2O, 4 H2O. What do we have? 2 H2O on this side. So let's formulate. And this is what? 2 plus 3. See over here. 2 plus 3. That makes it up addition. If it's on the same side, you add. If it's on the opposite side, we subtract. Okay. So this becomes 2MnO4 1 minus plus 4OH minus plus 3Mn2 plus, giving you 2 plus 3, 5MnO2 plus 2H2O, right? Now, there's some discrepancy of this with respect to your textbook. In textbook, they have not given this as an answer. They have given something else as an answer. So instead of writing 4 OH minus, so 4 OH minus is what? OH, 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 OH. Meaning H2O and H2O. Two H2Os can be separated, right? And there are 2 oxygens remaining. 2 oxygens remaining. 2 H2O means what? 2 H2O means we have 4 hydrogens separate and 2 oxygens over here, right? So in your textbook, we are expecting you to go one step further and do what? Cancel these 2 oxygens and then formulate your equation. Reason being, in all the reactions that we have seen, on the reactant side, we generally have water. See the previous one. Reactant side, water. Reactant side, water. So even on this side, we want water, not hydroxyls, because we are adding it in a neutral medium. That's why we need to convert 4 hydroxyls into water molecules. So what do we get? 2MnO4 1 minus plus 2H2O plus 3Mn2 plus, giving you 5MnO2 plus, instead of writing 2 water, we write 4 protons. Okay, and with this, we end our lecture over here. I hope you have understood how to react KMnO4 in slightly alkaline or neutral medium. Signing off. Bye.